In this week's lab, we designed our own ALU, arithmetic logic unit. Arithmetic meaning relating to arithmetic. An ALU is a circuit that does various math equations, such as adding or subtracting, as well as comparing numbers, and is one of the primary parts of CPUs. Modern ALUs can be very complex and capable of doing many different calculations in addition to what ours did, such as subtracting or various types of shifting. For now, we're just focused on what our ALU needed to do. The ALU we designed consisted of two 4-bit numbers, A and B. These numbers would then be processed by a 4-bit adder and 3 bitwise operators, AND, OR, and XOR. The results would then be processed by a mux array to determine which result to use after this circuit, in this case, to light up some LEDs. Let's start by hooking up the numbers to our eventual operator circuits. Here we have our two incoming 4-bit numbers, which we then proceed to hook up to what will be our operators. Each bit needs to be hooked up to each unit, which I decided to do as so. You could also do this by bundling the wires together to make the circuit look a little cleaner, but I preferred this unbundled look. This wiring could, of course, be more compact, but I find the gaps between the grouping of bits to make the circuit more readable. Once we've hooked everything up, we can get into what each operator does. The first 3 are rather simple. We merely need to compare each comparable bit to each other using the gates of the same type of the bitwise operator. So for XOR, we use XOR gates. For AND, we use ANDs, etc. Bit A0 needs to be compared to bit B0, A1 to B1, etc. Each output from the gate will then exit through its own output pin. Then we come to the 4-bit adder. This one is a little more complex than the bitwise operators. For this, we need to add each bit to each other and make sure to carry the overflow, if there is one. The easiest way to solve complex problems is to solve their individual, simpler parts. Following this idea, we can create a 1-bit adder to add 1 bit at a time. Luckily, the 1-bit adder is fairly simple. It should have 3 inputs, bit A, bit B, and another bit in case the previous adder had to carry. It also should have 2 outputs, the sum of the 3 inputs, and a carry output. The sum is rather simple in binary math. A 3-input XOR gate will determine if the output needs to be a 1 or a 0. Do note that this XOR gate needs to output 1 if an odd number of inputs are true, rather than if only 1 is true. The carry output is a little more complicated, but still pretty simple. If any 2 inputs are true, we need to carry. We can use AND gates to compare all possible combinations of inputs, and an OR gate to see if any of them are true. Once our 1-bit adder is working, we can chain them together to process any size number we want. We'll use 4 of them to process our 4-bit number. We'll take A0 and hook it into the same 1-bit adder as B0, A1 with B1, etc. We also need to hook up the carry outputs to the carry inputs of the following adder. The first adder won't have a carry input, so we'll use a ground to set it to 0. Likewise, we aren't handling overflow, so the last carry output can just go into the ground. The results of each adder will go to its own output. Now that all our operators are working, we can hook them up to some mux units to determine which output we'll use. The wiring for this is a little bit tricky. We're going to use 4 4-input mux units. Each bit from each operator goes into its own mux unit in the same position as the other bits. For example, the first output of XOR will go into mux 0, input 0. The second output will go into mux 1, input 0. And the first output of AND will go into mux 0, input 1, and so on and so forth until all the operators have been hooked up. The selectors then need to be bundled and hooked into the mux units. Finally, the outputs of each mux unit go into its own output pin. Once this is complete, your ALU should be done. With a few tweaks, you could add a subtractor module or even create a larger ALU if there was ever a reason for you to do that. Thanks for watching and good luck on your projects.